Alrighty, welcome to week 3. We're going to be doing classes and objects today. This is one of the trickier lessons generally. So I do expect there to be questions and I welcome them. Okay, so just feel free to interrupt me as we go. Although this is a pretty small in-person class today, so we'll see. A couple of notes just from the last week. So I've gotten a lot of questions about whether there will be homework for this class or not. Unfortunately, this is a free class, and also there is, we meet once a week, and it's free to attend, which means that a lot of people tend to struggle with commitment, which I know is a statement about New York in general, but also to this class. And so I think if I assign a bunch of homework, I get the feeling that I'm going to start losing people very rapidly. Additionally, I don't have the energy to make homework, so I will not be making homework for this class. But yeah, I will have projects. And on that note, the first project is due at the end of the day on Sunday. So there's a sign up link to CodePost. Once you have signed up, you should see the first project submission and you can submit it there. For future projects, I'm going to have an auto grader. This one I'm just going to grade by hand. Partially because there's a very small bug in the project itself, which I'm not going to get into, but don't worry about it. Most of you will never find it. But yeah. Couple of notes on today's timeline. So we're going to be doing, talking about what an object is for probably about 15 to 20 minutes. And then what a class is for another 10 minutes. And then the structure of a class for probably about another 20 minutes. Then I will take questions for about 20 minutes, although this is probably going to be pretty short today, just because we don't have, we only have one person in the classroom with us, and she has actually already gone through this. So this may be a faster lesson, but if you do have questions, feel free to, drop them in the Instagram group chat. Or, if you're watching this on YouTube, you can leave a comment and I will do my best to answer. And then I'll be opening the floor to questions on the project, either the little mini in-class project around primes that we did the other day, or the take-home project. Okay, so starting off with what is an object? Yeah, normally I would go around asking people what an object is and getting suggestions, but today we only have Emma. So Emma, what is a project? So what is an object?
There you go. A noun.
Jerk. You watched me write these. Anyways, yes, an object is basically a noun, like a person, place, thing, or idea, and it has to be something tangible. Basically anything that you can describe as a tangible thing. This could be as real as a block of cheese or as abstract as some kind of connection, right? We often will have connections represented as objects in code. A connection from a client to server, we might want to send data across it. That connection is an object. In Java, almost everything is an object. That's why it's called an object-oriented language. Now, what is a method? A method is basically a verb, right? Anything that an object can do, or that anything that you can do to an object, right? For a house, right, you might be able to get the number of windows on that house. You also might be able to burn the house to the ground, right? In one of those cases, or in both of those cases, there are things that you can do to the house, because a house obviously can't really do anything on its own. But a person could run, right? A person can get older. A dog could die, right? All of these different things, some of them more sad than others, but they are things that either the object can do or things that you can do to the object itself. So now I'm going to get to the part that tends to confuse people. So this is about what is a class versus an object. Now remember that class, well, you haven't really seen any examples so far. So actually, I might break from protocol a little bit, and I might show you a quick example of a class. But at a high level, what a class is it's the idea of an object. It is basically what you're actually coding. You're coding effectively a recipe or a template on how to build an object. For example, if we define a person, right? The person class might have a name and the ability to run, and a location, right? And an energy level, right? Or you can think of it, for those of you who play Dungeons and Dragons, of which I know there are quite a few of you who do, these are basically your characters. Your character, a character sheet is a class, and then your object is the actual, filled out character sheet, right? What is my character's name? What is their race? How much health do they have? All that stuff. So it's basically a template, which is the code that you're actually writing. Meanwhile, an object is how you're using that template and creating instances of that template in code. So I'm going to quickly show you an example, actually, with the intent of making this a little bit easier to understand. So I'm going to make a new folder for lecture, what are we on now, 3? And for, JGrass keeps doing this. It won't let me open folders, which is very annoying. There you go. File, new Java. We're going to have a public class, tester. And it's just going to have our public static void main string args. Right, no big deal. Then we're going to have system.out.println hello world. Just to make sure that this works, we hit run, we hit save, we hit save. Good, code works. All right, so now let's say I want to make a person, right, or a character. So I first need to define what is a character, right? What can a character do? So to do that, we're going to go to File, New, Java. We're going to create a public class character. And first of all, we're going to talk about what are the attributes of a character. I'm going to say a character has a name, which is going to be of type string, right? I'm going to say it has a string for race, and let's say a int for health, which I'm going to have as HP, right? Thank you, Emma. Right, and I'm just gonna, for now, when we actually create, this is gonna be the constructor, which I'll talk about in a minute. This is gonna set the character's name to, Cole. My race is gonna be human. And my HP is gonna be equal to 20. I'm not up to date with, I don't know if, I'm not up to date on D&D. I don't know if that's good or bad. Probably bad, but I don't know. All right. So if I create a character, Cole equals new character, I can then system.out.print print line Cole.name. And if I run this, it will print Cole. And the reason is because after we've created our character, Cole is set to, or Cole.name is set to Cole. Right? Now, getting back to this, I want to stress what we just wrote there is a class. This section here is a class, public class character, right? This is a class definition. In our tester, we're actually instantiating the class. This is now an object. We're creating a instance, a new character, an instance of the class character that becomes an object. And if I use the debugger here, it actually becomes pretty easy to see. So if we look at Cole here, we can even see that Cole is a character object, right? And if we look inside of it, it has an HP, a name, which is a string, right? An HP, which is an int, a name, which is a string, and a race, which is a string. And we can even see the values, right? So this is our object. You can have multiple objects, right? For example, if I wanted to have Emma here as well, I can then also set Emma dot name equals Emma.
The other class character.
Give me 1 second just to finish this demo, and then I'll take your question. Oops, I hit run, not debug. So here we have Cole, right? Our name is Cole. And then in Emma, the name is Emma. Now, keep in mind, this is not because I named this Emma here. That's unrelated. It's because I set the value here. This is just the name of the variable. It has nothing to do with the name of the actual character. It's like the name field of the character. Okay, what was your question?
Would the Emma.name go on character.job? That's where full on.
Yeah, so if I change this to Emma instead, every future, every version of character that is created, the default name is going to be Emma. So now, if I run this, it's actually going to print that both names are Emma. Oops. I don't think I saved this then, or something. Yeah, Emma, right? Even though it's Cole.name, it's because the default name for a character, when a character is created, its name is Emma. So now I would have to change this to be Cole.name equals Cole, right? Now, before we get too into that, I want to talk about the different parts of the class, because you've already seen two of them. One of them is the instance variables. These are basically attributes. You know, if you're coming from a video game, you know, they're just the attributes of your character. For non-video game related or people, attributes are basically just anything that you can describe about the object, such as a name, an age, a color, right? If you have a box, you might have a length and a width and a weight, right? If you had a person, you'd have an age, probably. A building might have a number of doors. A connection is either alive or dead, so it might have this is alive, right? You then have a constructor, which is what needs to be done to each instance variable when creating a new instance. So if we hop back to our example here, inside of character, these are our instance variables here. Instance variables. This is our constructor. I only built one constructor, but you can put multiple constructors because there might be multiple ways to build an object, right? It can take parameters. I didn't take a parameter here, but I can adjust this later to take a parameter, and I'll show you what that looks like in a minute. It also has methods, which I did not define any methods here. Oops. But we can definitely add methods. Methods are basically the actions that an object can take, right? And they can take parameters as well. So for example, I might define that we can have a method that allows me to take damage, right? And I need to know how much damage, right? And I'm going to define this as if I'm taking some amount of damage, I'm just going to HP equals HP minus damage to take, right? And what this means is that I'm going to update my HP, my instance variable for HP, to be equal to the current value of HP minus the damage to take. So if I'm going to take, if I start with 20 HP and I take 10, right, we're going to set it HP equal to 20 minus 10, which is 10. So HP is going to equal 10, right? So that's a method. And I know this is going to be pretty confusing at first. And I am sorry that I'm doing this on a week where most people are not available, but I will be available in the chat with any questions you may have. And I like to think I'm a pretty decent responder for things like this. But yeah, demo time. Yeah. What's your question?
Okay. Wait, sorry, go to method. Oh, shoot, character methods. Where are you declaring? You're declaring that any damage you take right there.
Yes. So this parameter is a declaration.
But would the damage you take not be in the instance variables?
So damage to take is a parameter. We want to accept this as a parameter of our method, right?
But you don't need to declare it.
Well, we're not trying to store it. These are the things that we're storing. They're what make up our character, right? Our character in our case has a name, a race, and a health, right? How much damage our character is taking is not part of our character. right? It affects our character. It affects our character's health, but it's not part of our character itself, right? For example, whether or not, or how you've been traumatized in your past doesn't define who you are, right? It affects who you are, but that the actual specific trauma is not something that we need to store as part of a person, right?
Okay.
For example, a box, might be picked up or not, but that doesn't affect the box itself, right?
What's the public void for?
Yeah. So public and void are going to be a little bit confusing. So methods, I will get into this more in the next class, because, oops, let me just adjust the camera here because it's also where my feet need to go, and I am cold. Okay. So a couple of things. Public and void. So I'm going to break this into two things, but I'm actually going to slightly delay your question for just a second. And I want to talk about projects. In JGrasp, if you have multiple files, you should be making a project. So we're going to go to project, new, and we're just going to call this, I don't know, character things. Okay. I'm going to hit next and I'm going to hit create, right? And then I'm going to right click on this and I'm going to click add to project and the other Java file and add to project. We don't care about the class files, okay? You can ignore them, but all the .javas need to be added to this project. And what that means is that when I try to run this test, or the main method inside of this tester class, this is going to automatically compile the other files that exist. So that's going to be good for us. If you don't know what that means, don't worry about it. You'll figure it out on your own time eventually, the hard way, most likely. But just keep in mind you need to add them to a project. Now, as for what public and private mean, or public means versus private, so you're really only ever going to see two values here. You're going to see public or private, right? Now, there are actually a couple of more values that are valid there, but we're only ever really going to talk about public and private. So we're going to set race to private. Okay? Actually, we're going to set HP to private. Apologies. Private. So remember here where I was able to do, character.name equals Cole. That's because name is a public attribute of character, a public instance variable of character. And that means that we can access it from other files. So even though it's defined and declared inside of the character.java, we are able to use it inside of tester.java. If I try to do col.hp equals 10, this is going to throw an error. And it's because HP is private, right? That just means that we cannot use this directly. It's not just that I can't update it. I can't even read it either. Right? So at no point through here am I going to be able to, get the value of the HP from my character. Now, there are a couple of reasons that we might do this. One of the easiest is to signify, hey, this variable is not supposed to be modified. This attribute is not supposed to be modified outside of this class, right? But for now, we're not going to get into that too much today. We're just going to leave these all as public, and I will get back to that in the next class. This section or this class is hard enough to understand without getting into public and private. As for void, this is a really good question. Methods can often do a whole bunch of different things. And oftentimes it's beneficial to actually get a value from them. So for example, we have this take damage, right? We also might have a method where we get an introduction, right? And in this case, we don't need any parameters, but we're going to have it return, and I'll cover what this all means in a second. We're going to return, hello, I am, and then our name, and then a period. I am a, and then our race. Oops. And I have a whopping, and then our HP, health. Fear me. Right, something like that. Now, why is this useful? This is useful because in here, for example, let's say I have these two characters now, right? We have Cole and Emma with our names set appropriately, but we are both humans. Now, what I might want to do is I might want to actually introduce these characters. I want to get a value out of these characters. So I can system.out.print line, and I can actually do Cole.get introduction. And you'll notice I have these little parentheses at the end. This is because get introduction is a method as opposed to name, which is just an attribute, right? So name is just an instance variable up here, but get introduction requires the parentheses because it may take a parameter. So if I have both myself and Emma's characters introduce ourselves, we will see, hello, I am Cole, I am a human, and I have a whopping 20 health, fear me, versus hello, I am Emma, I am a human, and I have a whopping 20 health, fear me. Right, this makes sense. If we actually look at what's happening in this code, right, we now, we're at this little line 10. This is right before we have actually, gotten this introduction. We can look at Cole. We can see that I have 20 HP, my name is Cole, and my race is human. If we step inside, so we're going to click this little arrow, this step in for selected thread. Don't worry about the for selected thread. We're going to step into this, which means we're going to go inside the method call here, which is get introduction. We are now inside of the character Cole. So if we look at this, we're going to see that our HP is 20, our name is Cole, our race is human. And if we then, look at this, right, we're going to say, hello, I am name, which is Cole. Hello, I am Cole. I am a race, which is human. I am a human. And I have a whopping 20 health. Fear me. That is going to then be returned back to here. So this just got replaced with, hello, my name is Cole. I am a human. I have a whopping 20 health. Fear me. So this is now going to print, hello, I am Cole. I am a human, and I have a whopping 20 health. Fear me, right? Likewise, this same thing will happen for Emma. And then we hit the end of the program. Now, if I take damage, right? So we have Cole dot take damage, and let's have me take 5 damage. Emma, can you tell me what the output of this is going to be? Yes, you can. Try.
Can I see the other? So it would be the new HP is 20 minus.
Would it? So let's actually step through what's happening here. So first, we have Cole.get introduction, right? This is just going to print our standard, hello, I am Cole, I am human, I have a whopping 20 health, fear me. Then we're going to take damage. We're now going inside of Cole. Not like that. And we're going to have HP is 20, name is Cole, race is human. But we also have this parameter, damage to take, which is 5. The reason this is 5 is because we passed in 5 here. That becomes the first argument. So we're going to set HP equal to HP, which is 20, minus damage to take, which is 5. So we're going to be setting HP to 15. Right? HP is now 15. And we don't return anything. That's what this void means. Here we're returning a string. Here we're not returning anything. Sometimes we return a string, sometimes we return an int or any other kind of value. We might even return a character, right? However, we're not going to have, we're not going to have anything else. We're not going to return anything from void, sorry. So then we're here. And now it's time. So Cole now has 15 health. And then we're going to print Emma.getIntroduction. Emma, on the other hand, has 20 health. So we're going to say, hello, I am Emma. I am a human. I have a whopping 20 HP. Fear me. And the reason is because we updated the damage to Cole, but never printed out Cole's introduction again. Right?
You just run it.
You want me to run it one more time? There we go.
It says Cole has 20.
Right. That's the point. Because we printed my introduction before updating my health. We never reprint. If I copy this line and put it below here, now we're going to have 3 output lines. The first one is going to say that I have 20 health, and the next will say I have 15. Right? Now, excuse me. This is generally how we work with objects. There are either methods that do things to an object, such as take damage, or methods that get information back from an object, like get introduction. Sometimes you have both, right? We might want to modify this take damage so that it returns an int, and it can just return our updated HP. Why might we want to do this? I don't know. It'll depend on our use case, but it would mean that we can say system.out.print line Cole takes. Here, we're actually going to make a little int here. Cole takes plus num damage plus damage, leaving him with a measly health. Right? And this, because this now returns an int, it will return the updated health. It will both cause me to take damage and then return my updated health. Ah, I need to close parentheses. Yep. Thank you. Right, just looking at this error, says it's expecting either a comma or a parentheses. And if we look at this, we can see a little caret showing where, which sure enough, it needs a parentheses. So Cole takes 5 damage, leaving him with a measly 15 health. And hello, I am Cole, I am human, and I have a whopping 15 health. Fear me. Any questions on anything so far? I think this is going to be a pretty short class for today, because I was expecting there to be a lot more questions, and I'm sure there will be as people start to watch the recording.
If we go into character.java.
Yes.
Right. Could you potentially write like Emma dot name equals Cole? And then
So part of the problem is that inside of this is just a recipe for a generic character. There is no concept of Emma versus Cole.
okay, so that all has to
So this is just any generic character, right? And you might think, well, it doesn't really make sense to assign all characters to human. And I would agree. I'm going to say that all characters should actually we need to take in their name and their race, right? To character race. Okay. So I'm going to replace Emma so that we're updating it with name, and I'm going to replace human so that we're updating it with character race. And this is where things get a little bit confusing, because you might notice name equals name looks like a pretty stupid statement, and that's because it is. Name, we now have 2 name variables. We have a name as a parameter and a name as an instance variable. Now, the easiest way to avoid this is to just do something like this. Character name. And then we could just modify it like this so that it will actually just work correctly, right? And this will now make it so this name is referencing this one, and this name is referencing the local variable. However, if we, for whatever reason, didn't want to do that, and we insisted on the parameter being equal to the lowercase name. The way that we clarify that we want to talk about the instance variable name is with the keyword this. So we do this dot name equals name. This dot name is referring to the instance variable name. Name without this dot is referring to the local variable name, which in our case is a parameter. Does that make sense?
Yes.
Okay.
Go sorry forward again. That'll
What do you mean?
when it was character name, where are you like it's like
Character race? It's right here.
and character name with oh I see.
So yeah, I had to change the name up here. But these variables are declared right here.
Okay.
Right? So now we're going to get an error because this constructor is expecting 2 arguments. Right? It requires 2 strings, and it found no arguments. So we need to give it 2 strings. For Cole, the first one is going to represent her name. So I'm going to be Cole, and I'm going to be a... You know, I've always wanted to be a Dragonborn. That seems kind of cool. And Emma, what do you want to be? You could be a Dryad. I don't know, they're like the tree people, right? Yeah, they're like a tree spirit, basically. They're kind of cool.
I want to be a tree.
You don't want to be a tree? What do you want to be then? I asked you, and you said you didn't care. All right, well, you're a Dryad then. Right? So now, if I run this code, what's going to happen is that Cole is now going to be, well, actually, you know what? I'm going to move this up here so I can explain what's going on. Let's end this and let's restart. Okay, so this is before we've actually created the character Cole. If I step into this, we're now calling the constructor, right? This has HP of 0, a name of null, and a race of null, which makes sense. We've never actually given these initial values. So they're going to default to these kind of really broken, dumb values. We have 2 arguments. We have character race, which is Dragonborn, and we have name, which is Cole. So we need to set this dot name equal to name. That's the first thing that we're going to do, right? So this dot name is now Cole. We're then going to set the race equal to the character race. So we're going to watch this one update to character race. Now I could put this dot race equals character race, but I also don't need to, and I'm lazy, so I won't. Right? Thus, our instance variable race is now Dragonborn, and we're going to watch our health get updated to 20. And then we're going to see the actual creation. So right now we have created a new character object. We just need to assign it to this declared variable. And ta-da, it now exists. There's now Cole, who is a Dragonborn and has 20 health. Likewise, we're also going to create Emma in much the same way. Her variables are slightly different. Our character race for her is Dryad, and our name is Emma. So this dot name becomes Emma, and our race becomes Dryad. And our health becomes 20. Forgot about that. And then we're going to also create our num damage for 5, just because we use it later down here for this example. But if we go inside of this declaration, or not declaration, we go inside of this method call, we're going to get that our, oh, excuse me. Thought I had a text. I was wrong. Okay, not important. We were able to get this. Where was I? I'm sorry, I got a little bit lost. Oh, so yeah, we're inside of Cole, and we're going to be getting this introduction. We called this get introduction method, so we're going to get the introduction, and we're going to get, hello, I am Cole, I am a Dragonborn, and I have a whopping 20 HP. Fear me. Yes, forgot about the fear me portion. Apologies. Then I'm going to take 5 damage, leaving me with a measly 15 health. I'm then going to introduce myself again for some reason. Still proud of my 15 health. And then Emma's going to introduce herself, which is fantastic, right? Now, we can do some fancy things here. For example, we might want to do something like, adjust different amounts of HP depending on the character's race, right? We might, which we could do with, something like, if race dot equals, Dragonborn, HP equals 100, or I don't know, 40, right? Else if race dot equals Dryad, right? HP equals, I don't know, 15, right? And then else HP is going to be equal to 20. Right, now you might notice that I'm using the dot equals here. This is something that I did want to cover in a prior class and I didn't get to. Typically, when you're working with primitives, which are these, our primitives are our int, double, float, boolean, char, these kinds of characters, the ones that turn purple, you can actually just use the double equals to compare two values. But then for objects like string or characters, you need to use this dot equals method here. So in our case, now, if I go back to our tester and I try rerunning this, you're going to notice, once it runs, that I start out with 40 health. And even after taking 5 damage, I still have 35, right? Emma is a dryad and starts with 15, which is fantastic, right? Or not for her, but that's what's supposed to happen. We also might have a type of method that checks if somebody's alive, right? For example, we might have a public boolean is alive. And all this is going to do is if our character's HP is greater than 0, it's going to return true. Otherwise, it's gonna return false. Right? So in this case, it takes no parameters because we don't need any additional information outside of our own attributes. It's going to return a Boolean, which is either true or false. And it's public because we want to be able to use it from other classes, right? So I can say, for example, that, system.out.println, line. Sorry, I can do actually if full dot is alive, right? Then we're going to print that Cole is still alive. Else system.out.print line Cole is dead. Bleh. Right? And if we run this, we're going to see that I am in fact alive, right? Cole is still alive because I do still have 35 health. Now, if I were to take more damage, Cole dot take damage. If I take, 40 more damage, I will die. Likewise, Cole is dead. Bleh. And we can even do some fun things. For example, in our get introduction, we can say if is alive. And notice how I'm not prefacing it with full dot is alive, because here we're just referring to whatever instance of this object that we're in. So if we are alive, if our character, our generic character that we don't know which one we're talking about yet, but if our generic character is alive, we're going to return that. Otherwise, we're going to return bleh. Because that's all dead people can say. So you can go bleh. Okay. So if I then take this damage, right, and Cole is dead, bleh, and then I try to introduce myself, we're gonna get that bleh, right? And we can even see exactly what's going on here. If we run the debugger, right, I take 40 damage. I step over that, right? Cole now has -5 health. So if we check in is alive, right, we're going to see that this has an HP of 5, name is Cole, race is Dragonborn, right? Which is why, by the way, this dot name refers to the instance variable. Literally, this name is the instance variable. So if our HP is greater than 0, which it's not, so we're going to return false. So we're going to go to our else statement, and we're going to print Cole is dead. Bleh. Right? And then we're going to check Cole's get introduction. So we're going to go in here. First thing it's checking is if is alive, and we can step inside of that as well. So you can see that while, we're running this, but we're actually running up here. And we need to get the result from this method first to then go back inside of here. We did return false. So we're going to go to the else and return bleh. Right? And then Emma is still alive, thus she still gets to say things. Now, it's very, very, very important to remember, code is still running from top to bottom in this main method. It's just that we are basically putting in subroutines, right? Little sections of code that run elsewhere, but they're still running top to bottom. When we get the get introduction, we check is alive. That's the first statement, which kind of basically puts this code, you can think of it as putting this code, right? Right here, you know? That's obviously not exactly what's happening, but it's pretty close. So then we're running just top to bottom, and then we're back here, and then we're running top to bottom, and then we're back here, and we're running top to bottom. And it's all that simple. Do you have any more questions?
Um, so we have two characters. We have Cole, we have Emma. Can we test just making the class character? Like just the generic character that's different and printing just that?
Well, so what would that look like?
It's a good question.
So are you saying like, what if I do system.out.print line like character dot get introduction?
Or is it called testing?
Well, tester is just the instance of this class. You can ignore that.
Well, you know, at the very beginning where it still said Cole has 20 HP and
Yeah.
it's 20 HP. Where was that?
Oh, that was because I had this code that I deleted. I don't know.
Um,
Right? So I have hello,
Yeah.
I am Cole, I'm Dragonborn, I have whopping 20 health. I'm Emma, I'm a Dryad, I have 15 health.
we go to the place where you declare the health in the beginning.
Oh, in the character?
Yes. So if, let's say, instead of saying,
Oh, you want me to make a character that's not a Dragonborn or a Dryad?
yeah, and it's going to be like a general character.
All right, so we can do Connie
So you have to have a name.
and human, right? And if we do Connie's introduction, you're gonna get, hello, I am Connie, I am a human, and I have a whopping 20 health. That's from here.
Okay.
Does that answer your question?
I see.
because race is not equal to Dragonborn. It's also not equal to Dryad. So it's gonna be 20 HP.
I,
Yep.
then I was wondering if it would be helpful to go over the project. Um, walk through that.
I could go over the project, but it's not due yet, and there are a couple of people still working on it.
And then lots of video.
Okay, yeah, you know
That'd
what?
be helpful.
Fair, because everyone else is gone. So if you're still working on project 1, spoiler time. Let me go back to spoiler time. Yes. Okay, just spoilers. If you haven't done the first project, stop the recording, finish the first project, and then come back. Okay. So, close out of these. And we can go to binarysearch.java. So, this is the starter code without hints. Goodness, it's annoying. I'm going to make a copy of it real quick.
Because it's a set file. I can't.
No, sorry, that's starter without hints. I'm going to rename this to binary search demo.java. Okay, if I refresh this, it should show up. I just don't want to modify the actual starter code. So because the file name's different, I got to modify this, but then we should be good. Okay, let me just test real quick. Nice. Okay. So our goal is to try and find the number defined here in thank you. The number defined here in the minimum possible number of attempts. Right? So we have a huge range of numbers, about 4.2 billion, almost 4.3 billion possible values. Excuse me. Just checking to make sure Himanshu is not here yet. He is not. But yeah, we're checking to see if we have or we have about 4.3 different possible 4.3 billion different possible values, which is a huge number. But we can actually provably guess the number in 32 or fewer guesses. The way that we do that is every time we guess, we're going to guess right in the middle. So I'm going to do a little demo here. So this is our number line, right? This is our min guess out there, right? And then out here is our max guess. So our actual guess, we're always going to choose to be right in the middle, right? Now, if you tell me that the number defined is actually, greater than guess, then I can delete this entire half of the number line. If you're telling me it's less than, I can delete this half. And if it's equal to guess, then we just got it. So that's great. But you can see that we went from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Times 2 is going to be 36 possible values. We're now down to 18. So let's assume it's less than, because I'm going to go with the number that Emma's thinking. Right? Now we check in the middle again. Right? And this is now our actual guess here in the middle, with our max guess being, our maximum value. We then find out, okay, it's less than this. So this becomes our max guess, and then our guess again becomes exactly halfway in between. And we're going to keep doing this, right? Eliminating half of our possible values every single time, right? Until we're eventually left with only a single possible value, and that we will eventually guess, and that becomes our number, and that's how we're going to get our number defined. So, how do we actually code this? Well, what we're going to have to keep on our gut instinct is that we're going to have to keep on guessing. We might get really lucky. We might guess it on the first go, right? But we might have to keep guessing as well. So we know that we're going to have to do more, or, the guess process more than once. So I'm going to say, at some point we're going to have to guess, and then we're going to need to do this multiple times. And because I know that we're going to be doing this multiple times, that means that we're going to have a loop, right? And because we don't know how many times, I'm going to go with a while loop, personally. Now, oftentimes I like to, when I'm coding and I don't know the answer, I just put while true just for a minute, just so I can think about, what I'm doing, right? So let's actually, we can revisit this condition, this while condition, because obviously this would never actually end. And let's program the guess. So the guess is going to be very simple, right? We already basically taken our first guess here of 0. So we first need to check if our guess is correct. So our steps are to check if the guess is correct. If it is, we are done. If it is not, we need to adjust the min and max value, min or max value accordingly. Right? So first, check the guess is correct. All right, if guess is equal to number to find, right? If it is, we're done. Now, what do we do if we're done? Kind of nothing. So I'm just going to leave that blank for now, and we'll come back to it later. Oops. Right? If it's not, we need to figure out, is our number bigger or smaller? So we can say if our guess is less than our number to find, if our guess, remember our timeline, or not our timeline, our number line, sorry. If our guess, if we know that the number to find is less than our guess, what we want to do is we want to trim off the entire right-hand side of our number line, which basically means we're reducing our maximum possible value to our current guess. So that we know we're going to be doing our max, what did I call it? Max value, I think?
Max value.
Yeah, max value going to be equal to our guess, right? And if it's not less than, if our guess is not less than our number to find, and we also know it's not equal to our number to find, then the other case here, sorry, if guess is less than number to find, that means the number to find is greater, which means we actually need to increase the min value. Apologies. That's my bad. But if our guess, so this is for our guess is less than our number. And then on the other hand, that would mean that it's greater than, right? Which means that if this is our line, this is our guess, we know that it's on the right-hand side, which means, we know that our guess is greater than our number to find, which means our number is on the left-hand side of the number line. We need to get rid of the right, which means we need to shrink our max value. Right? So eventually, we're going to keep cutting our number line in half. That's what's happening here in this while loop. But we still have this bit here. Our guess, if our guess is number defined, we're done. So really, if we're done, we want to exit this loop. Now, this can help us figure out what this condition is going to be, because we're really doing this while our guess is not equal to our number to find, right? And at this point, we can remove this if statement, which means we can also, sorry, which means we can also remove this else statement, because it's no longer useful. And then we unindent that just so we have a cleaner code, right? So at this point, if I run this code, I want to make sure that we exit this loop. Because if we exit the loop, that means that we have found the number to find. And we did, right? And that's great. So let's test with a different value of number to find, because obviously this makes sense. Our guess starts out as our number to find. So if we change our number to find to, let's say, 40, do we find it? The answer is no, we don't find it. So this is interesting. This tells me that I've made a mistake somewhere. The reason this is still, or we're not printing anything, is because we never actually exited that loop. So I'm going to hop into our debugger. This is always the downside of live coding. You can make mistakes, and it's annoying. All right, so our guess, while our guess is not equal to our number to find, our number to find is, by the way, I want to call this out. Emma, being a sweetheart, just tried to show me her solution code. Thank you. But I do want to go through, in this debug process properly. So while our guess is not equal to our number to find, we're going to enter, and we're going to check if our guess is less than our number to find, which it is. So our min val gets updated to our guess. And then we check if our guess, which is 0, is less than our number to find. And I think I'm already seeing the problem. We're not updating our guess ever. So I forgot a step. So after we finish making the guess, we need to update our new guess. So we can do that by setting we need to update our guess. So we're going to set our guess equal to halfway in between our minimum value and our maximum value, which we do by which we get by doing min value plus max value over 2. And that's just how you take the average of any two numbers. So if I run this again, hopefully this will at least exit. Good news is we do exit. The bad news is it definitely took us more than one attempt. This 1 is coming from the counter, which means that we're probably just forgetting to update the counter inside this loop. So if we have entered this loop at all, that means that our guess is not correct. So we know we're going to have to make another guess. So we can just increment our counter here. So counter plus plus. We know our guess is wrong and need to make another. Oops, another. So if I run this now, we should see that we're able to find the hidden number 40 in 32 attempts. And this makes sense because that's what this is. So if I add these two numbers, if I add these two numbers together, right, we're going to get, plus the 1 for 0, right? We're going to get this. This number seems really, really intimidating, right? This is the total possible number of values that an integer can hold. But this number is actually not that bad. Because we're dividing by 2 the first time, and we're dividing by 2 with the second guess, and the third guess, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th, 21st, 22nd, 23rd, 24th, 25th, 26th, 27th, 28th, 29th, 30th, 31st, and 32nd. So you can see that within 32 guesses, we will always get down to exactly 1. And this actually makes a lot of sense, because the reason this number is because an integer is stored in 32 bits. Bits are numbers that are either 0 or 1. Actually, I'm going to pull this, make comments down here. So a bit is either a 0 or 1. And an int is made up of 32 bits, right? Which looks like okay, that's 32 bits. No, that's 32 bits. And if each of these can be a 1 or a 0, right? We have how many possible values? Well, how many possible values in 1 bit? 2, right? What about 2 bits? Well, we either have 0, 0, 0, 1, 1, 0, or 1, 1. So it's 4. How about for 3? Well, you have 0, 0, 0, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, or 1, 1, 1. 0, 1. What?
0, 0.
Oh yeah, you're right. I skipped 1, didn't I?
Yeah.
There's 0, 1. Apologies. I think I might have skipped another one too. But no, I didn't. Okay, so that's 8. And you'll notice it's the same, or it's just twice the number of the previous one. And you'll actually see this is a bit of a pattern. And it makes a lot of sense. Because really, all it is it is the possible values from the previous one prefixed with a 0 or prefixed with a 1. Thus, we're going to end up getting 2 to the first possible values for 0. For 2 bits, it's 2 to the second possible values, and for 3 bits, it's 2 to the third. Which means that this is 2 to the 32nd possible values, which, if we look at this number, is exactly what we expected it to be. That's why it takes us a maximum of 32 guesses, because we're able to cut down the number of spaces here by 2 every time. Basically, we're able to chop off one of these numbers every time with every guess. So yeah, I just wanted to show you that just to see. And I think that's it. Any other questions?
Posting the solution.
I will post the solution once or after the due date. Monday morning, I'll post the solution. Or you can just watch this video.
Great.
Okay, thank you very much, everybody. I will probably be releasing another project on Monday morning. You'll have about a week and a half for that one. It's going to be based on a very simple project with classes. But yeah, sounds good. See you all next week. Bye-bye. How do I end the recording? This is embarrassing. I really should have, there.